Welcome to Dreamtime Science, where curiosity meets tranquility and knowledge flows like a gentle stream. Here we explore the wonders of our universe at a pace that soothes the mind. You know what's fascinating? I've been thinking about how, out there in the vastness of space, tiny asteroids can sometimes slip by Earth without us even realizing it. There's something remarkable about how close these silent travelers can come, almost like cosmic whispers passing right under our noses, and I can't wait to share just how close they might get before we even catch a hint of them. Should you find solace in these cosmic lullabies, consider becoming a regular dreamer by subscribing. Share what topics intrigue your curious mind in the comments below. Now, take a moment, adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. In the hush before midnight, when the world is draped in deep velvet and minds wander between wakefulness and sleep, our thoughts turn upward toward the great ocean of night. The stars, so steadfast and ancient, seem to keep their silent vigil. Yet hidden in the black between those distant fires, a different kind of wanderer drifts, asteroids, the silent shadows of space. They are neither stars nor planets, but something in between, cosmic flotsam, remnants of creation, slipping through the solar wind like forgotten memories. Asteroids have haunted our collective imagination for centuries, sometimes as harbingers of doom, other times as mysterious messengers bearing secrets from the dawn of time. Their stories are etched into mythology, woven through the tapestry of pop culture and whispered in the speculative corners of our minds. In the earliest days, before telescopes or mathematics unfurled the true scale of the cosmos, the night sky was a realm ruled by imagination and fear. Ancient peoples gazed upward and saw not just points of light, but living drama. The Greeks, in their myth-making, named the planets after gods and goddesses, assigning agency to the wandering stars. The fixed stars were the domain of fate, but the moving lights, planets, comets, and what we would one day know as asteroids, were capricious, unpredictable, and thus deeply meaningful. The very word asteroid comes from the Greek asteroides, meaning star-like. It is a curious label, for these objects, when glimpsed through early telescopes, appeared as mere specks, pinpricks of light, indistinguishable from distant suns. Yet they moved, betraying a kinship with the wanderers. The first of their kind to be discovered, Ceres, was spotted in the opening days of the 19th century when Giuseppe Piazzi, an Italian monk and astronomer, noticed a faint object gliding against the backdrop of Taurus. He had stumbled upon the first clue to a hidden population of celestial nomads. But long before their discovery, asteroids haunted our stories. The Greeks spoke of the Phaethon, the son of Helios, who lost control of the sun's chariot, scorching earth and sky before being struck down by Zeus. In this myth, scholars now see echoes of comet and asteroid impacts, cosmic events so rare and terrible that they would have burned themselves into the communal memory. The Norse feared the spear of Odin and the fiery end of Ragnarok, perhaps inspired by meteoric visitors that tore across the heavens. For every culture that watched the night, there were tales of falling stars and omens from above, sometimes portents of plague, sometimes the heralds of kings. As centuries unfurled and science began to unweave the sky's tapestry, the asteroid became less of a myth and more of a curiosity. Astronomers, peering through ever more powerful telescopes, found not gods or monsters but rocks and metal tumbling in a vast cold ballet around the sun. Some, like Vesta and Pallas, were massive enough to be worlds in miniature, pockmarked and ancient. Others, mere pebbles, drifted unnoticed even as they passed within a cosmic hair's breadth of Earth. Yet the mystique of the asteroid endured. In the popular imagination, asteroids remained agents of chaos. In the 20th century, new myths were forged in the flicker of cinema reels and the pages of pulp magazines. Asteroids became the bullets of fate, unpredictable, unstoppable, crashing through planetary atmospheres to bring about extinction or salvation. Consider the 1998 film Armageddon, its narrative built on a foundation of fear and spectacle. A vast asteroid, too large, too close, threatens to annihilate Earth, and only the bravery of humans can turn the tide. It is a story that blends scientific fact with the primal dread of the unknown. The asteroid is both villain and catalyst, a force so vast that it forces humanity to confront its own fragility and ingenuity. In literature, too, asteroids are both playground and peril. Arthur C. Clarke, in Rendezvous with Rama, imagined a hollowed-out asteroid as an interstellar arc drifting through the solar system. Isaac Asimov, ever the architect of cosmic intrigue, set tales among the asteroid belt, a region he painted as both frontier and graveyard. The asteroid, in these stories, is a stand-in for possibility, a place where the rules of earthbound life no longer apply. But there is a deeper current running beneath these tales, a subtle apprehension, born not just of myth, but of a dawning scientific awareness. Unlike the planets, which maintain a predictable stateliness in their orbits, asteroids are mischievous. They are the leftovers, the shards that never quite coalesced into a planet, the refugees of a solar system's turbulent youth. Their paths are not always steady. Over eons, they are nudged by the gravity of Jupiter, by collisions with one another, by the gentle but inexorable push of sunlight itself, a phenomenon known as the Yarkovsky effect, where the warmth of the sun imparts a tiny, cumulative thrust to a spinning rock. Some asteroids circle the sun in the main belt between Mars and Jupiter, a broad, rocky river of millions. Others, called Trojans, ride the gravitational eddies ahead of and behind Jupiter, like flotsam caught in a whirlpool. Yet a select few, perhaps the most unsettling, inhabit orbits that cross Earth's own path. These are the near-Earth asteroids, the silent shadows that can slip between our planet and the Moon without so much as a whisper. It is here, in the quiet corridors between planets, that the asteroid's mythic terror finds its echo in reality. For while the vast majority of these bodies are harmless, drifting at distances that render them little more than a curiosity, a tiny fraction come closer, sometimes uncomfortably so. They are the cosmic phantoms whose proximity goes unnoticed, whose presence is revealed only in the careful tracking of astronomers, or, in rare cases, by the sudden blinding flash of an impact. Humanity, for all its telescopes and satellites, is a latecomer to this realization. Only in the past few decades have we begun to systematically scan the sky for these objects. Early efforts were sporadic, the work of dedicated amateurs and underfunded observatories. Even as late as the 1980s, the vast majority of near-Earth asteroids remained undiscovered, their orbits mapped only in the most general terms. It was as if we were living on the shores of a vast, unseen ocean, blissfully unaware of the ships that passed in the night. Yet the evidence of their visits is written in stone, if one knows where to look. The surface of the Moon, visible even through a child's telescope, is a testament to the violence of the solar system's early days, a pockmarked record of impacts, each crater a fossilized moment of collision. Earth, too, bears the scars, though wind and water work tirelessly to erase them. The most famous is the Chicxulub crater, buried under the jungles of Yucatan, its ragged rim stretching for over 100 miles. 66 million years ago, an object perhaps 10 kilometers across struck here, unleashing a force beyond comprehension, darkening the skies and hastening the end of the dinosaurs. Such impacts are vanishingly rare on human timescales, but their possibility lingers in the background of our collective consciousness. It is a fear both rational and irrational, a low, steady drumbeat beneath the noise of daily life. The odds are remote, the risks well studied, yet the asteroid remains a symbol of cosmic indifference, a reminder that the universe is not tailored to our needs or our stories. This tension between myth and measurement, between fear and fascination, defines our relationship with asteroids. They are, in a sense, the most democratic of celestial bodies. Unlike the distant stars, whose light takes centuries to reach us, or the planets, whose orbits are as regular as clockwork, asteroids are close enough to touch, unpredictable enough to unsettle. They are reminders that, for all our mastery, there are still shadows we have yet to chart. And so, as night deepens and the world grows quiet, the mind drifts again to those unseen travellers. Somewhere above, in the darkness between constellations, a stone the size of a mountain may be passing, unannounced and unobserved. Perhaps it will never come closer. Perhaps, in 100 years, it will be nudged onto a new path by the gentle tug of Jupiter or by a collision with a sibling stone. For now it is silent, its passage marked only by the faintest flicker on a distant sensor. Yet the universe is not entirely indifferent. With each passing year, our watch grows more diligent. Robotic telescopes scan the skies, cataloguing new objects by the thousands. Algorithms sift through data, flagging those whose paths intersect with our own. Astronomers, once the keepers of myth, are now guardians of knowledge, mapping the orbits of these shadows with a precision undreamt of by their predecessors. Still, the work is far from complete. For every asteroid tracked, there are many more yet unseen, small, dark objects that slip through the gaps in our surveillance. They are the whispers at the edge of hearing, the shadows at the edge of vision. To live on Earth is to share the cosmos with these wanderers, to accept a certain measure of uncertainty, to find awe in the vastness and humility in our place within it. In the end, perhaps this is the true gift of the asteroid, not as a threat nor as a promise, but as a reminder that the universe is not static, that history is still being written in stone and light, and that we too are participants in the ongoing story of creation. As the night stretches onward and dreams begin to stir, we are left with the knowledge that above us, in the silence of space, the shadows still roam, unnoticed, unhurried, awaiting their moment in the light. And so the question lingers, gentle and unresolved. How close are these silent shadows really to the world we call home? What distances separate us from these ancient stones, and what stories do they carry within their cold, unyielding hearts? The night is long and the sky is vast, but the answers, perhaps, are closer than we think. High above the restless blue of our planet, where the thinness of atmosphere yields to the vastness of interplanetary space, the celestial stage is set for a dance that unfolds with both grace and chaos. Here, in the darkness between planets, asteroids, those wayward relics of planetary formation, trace paths so intricate that even our finest minds strain to predict their every step. Their motions are not mere straight lines or perfect ellipses, but a complex ballet of gravitational nudges, subtle perturbations, and the faintest breaths of sunlight. To track them is to attempt to read a cosmic choreography written in the invisible ink of gravity and time. The story of asteroid tracking begins with the simple act of noticing. In the early days of astronomy, before the advent of computers and the gleaming mirrors of modern telescopes, the discovery of an asteroid was a feat of patience and careful observation. Astronomers would scan the night sky, night after night, looking for a point of light that shifted ever so slightly against the tapestry of fixed stars. Such a point, if it moved with a steady purpose, might be an asteroid, one of the solar system's true wanderers. Each discovery was met with a sense of awe, but also with a dawning realization. These objects, though small, are many, and their orbits are as varied as their forms. To track an asteroid is to follow its journey through space and time, to predict where it will be tomorrow, next year, or a century hence. This is no simple task. The first challenge lies in the sheer number of asteroids, millions, perhaps billions, ranging in size from mountain-like behemoths to pebbles. Some are well-behaved, tracing orbits that keep them far from Earth for millennia. Others are interlopers, flung onto new paths by the gravitational tugs of Jupiter or Mars, or by collisions with their kin. Still others are so small and dark that they elude even our most sensitive instruments, slipping through the net of our attention until they come close, perhaps too close, to our world. Modern asteroid tracking is an enterprise of both art and science, blending observation, mathematics, and no small measure of intuition. It begins with the detection of a moving object, perhaps by an automated sky survey, perhaps by the practiced eye of an amateur astronomer. The first images capture the asteroid's position against the stars. With each successive observation, a pattern emerges, a motion, a hint of trajectory. From these breadcrumbs, astronomers construct an orbit, a mathematical description of the asteroid's path around the Sun. Yet, even with the sharpest telescopes and the fastest computers, uncertainty persists. Measurements are always imperfect, blurred by atmospheric turbulence, limited by the sensitivity of our detectors. An asteroid's position may be known to within a few arc-seconds, but in the vastness of space, this translates to thousands of kilometers of possible error. The initial orbit is only a best guess, a statistical cloud of possible futures. As more observations accumulate, the cloud shrinks, the orbit sharpens, but it never quite resolves into perfect certainty. The complexity deepens when we consider the forces acting upon these celestial travelers. Gravity, the great sculptor of motion, is never content with simplicity. The Sun's pull is the strongest, binding asteroids into elongated ovals or nearly circular tracks. But no asteroid is ever alone. The planets exert their own subtle influences, especially Jupiter, whose vast mass stirs the asteroid belt into resonant patterns and gaps. Even the gentle pressure of sunlight can alter an asteroid's course through a process known as the Yarkovsky effect. Over years and decades, this minuscule force, a product of sunlight warming one side of a spinning asteroid, can nudge its orbit, turning a harmless wanderer into a potential threat. To model these influences requires a symphony of equations, each term accounting for a different aspect of the cosmic environment. Astronomers use powerful computers to integrate these equations, projecting the asteroid's path into the future, yet chaos lurks in the mathematics. Tiny uncertainties in position or velocity can blossom over time, leading to wildly different predictions. The farther we look ahead, the less certain we become. For some asteroids, the future is a branching tree of possibilities, each branch representing a slightly different outcome. Most branches pose no danger. A few, however, may intersect the orbit of Earth. It is here, in the calculation of risk, that the limits of our understanding are most keenly felt. When a new asteroid is discovered and its orbit calculated, astronomers must ask a pressing question: will it come close to Earth? If so, how close, and with what probability? The answers are couched in the language of probability and statistics, for the future is never known with absolute precision. An asteroid's impact probability is a shifting number, revised as new observations come in. Sometimes a newly discovered object will briefly appear to be on a collision course, only for further data to reveal a harmless miss. At other times, uncertainty persists, and the world must wait, watching and measuring until the cloud of possible futures resolves. To manage these uncertainties, astronomers have devised a system of threat assessment, most famously embodied in the Torino scale. This scale ranks the risk posed by an asteroid from 0, no danger, to 10, a certain catastrophic impact. Most newly discovered asteroids score a 0. Occasionally one will rise higher, sparking concern and a flurry of additional observations. The scale is not just a measure of danger, but also a testament to the limits of knowledge. It reflects both what we know and what we do not. The tools of asteroid tracking have grown ever more sophisticated in recent years. Wide-field telescopes scan the sky night after night, capturing millions of images. Automated software compares these images, searching for the telltale motion of an asteroid. Machine learning algorithms help to sift real objects from noise and artifacts. The data flows to centralized databases where orbits are computed and risks assessed. Yet for all this technological prowess, the task remains daunting. The sheer number of small, faint asteroids means that many slip through the cracks, unseen until they approach the inner solar system. Consider the infamous case of 2008 TC3, a small asteroid just a few meters across, discovered only hours before it struck the atmosphere over Sudan. Its brief flash of discovery was enough for astronomers to predict its impact, but not soon enough to do more than observe. The event was a triumph of detection, but also a humbling reminder. There are many objects, small and fast, that escape notice until the last moment. The universe is not content to let us rest easily with our knowledge. Each discovery brings new questions, each observation a new layer of complexity. Some asteroids travel in families, fragments of ancient collisions that still share similar orbits. Others are loners, their origins a mystery. Some tumble chaotically, their rotation rendering their paths even harder to predict. Still others are hidden by the glare of the sun, only emerging into view as they swing outward in their orbits. The challenge of tracking these bodies is compounded by the dynamic nature of their environment. Collisions between asteroids are rare, but when they occur, they can spawn clouds of debris, each fragment a potential new risk. The gravitational influence of planets can shift orbits in subtle ways, sometimes sending asteroids into the inner solar system, sometimes ejecting them to the cold outskirts. Even the gentle drag of interplanetary dust, invisible to the eye, can slowly alter an asteroid's trajectory over millions of years. Human ingenuity has risen to meet these challenges with creativity and persistence. Space missions have begun to visit asteroids up close, mapping their surfaces and measuring their masses with unprecedented precision. Radar observations, bouncing signals off nearby asteroids, provide detailed information about their shapes and spin states. These close encounters refine our models, turning abstractions into realities. Yet for every asteroid visited, there are countless more that remain mere points of light, their secrets locked away in the darkness. The limits of our understanding are not just technical, but also philosophical. When we speak of probability and risk, we are forced to confront the nature of knowledge itself. To predict the motion of an asteroid is to grapple with the inherent unpredictability of complex systems. A small error in measurement, a missed observation, can have outsized consequences. The future, always uncertain, becomes a tapestry woven from possibility and probability, and so the work continues. Night after night, telescopes sweep the sky, searching for new wanderers. Astronomers refine their models, update their databases, and prepare for the unexpected. The task is never complete, for the solar system is a living, changing place. New asteroids are born in collisions, others are lost to the sun or flung into interstellar space. The dance goes on, intricate and unending. As you lie in the quiet dark, consider the unseen multitude above, a swarm of ancient stones and iron, each tracing its own path, each shaped by forces both seen and unseen. Our efforts to track and understand them are a testament to human curiosity and vigilance, a desire to find order in the seeming chaos of the cosmos. Yet, even our best efforts are bounded by the limits of knowledge, by the inherent unpredictability of nature. In this hidden dance of celestial bodies, we are both observers and participants. The Earth itself moves through the swarm, our home a blue vessel sailing through a sea of ancient debris. The orbits of asteroids shape our destiny in subtle ways, their paths intersecting with ours on timescales both short and long. Some bring only a fleeting flash of light in the night sky, a meteor, a shooting star. Others, rare and powerful, have shaped the course of life itself, their impacts leaving traces in stone and memory. The search for understanding is never finished, the dance never fully mapped. Each new observation is a step closer to clarity, yet also a reminder of mystery. The cosmos offers no guarantees, only the promise of discovery and the challenge of uncertainty. As our telescopes peer deeper and our models grow more refined, the hidden dance of celestial bodies continues, complex, beautiful, and forever just beyond the edge of perfect knowledge. Somewhere, even now, a faint point of light is making its way across the sky, unmarked by any eye, its future unknown. The story of its journey and of our efforts to divine its path is still unfolding, a quiet drama playing out in the deep dark above, waiting to be traced, measured, and perhaps one day understood. Long before the modern world hummed with electric light, before the sky was dulled by the orange haze of city glow, there were only the stars and the infinite black between them. In that velvet darkness, sharp-eyed stargazers sometimes noticed faint, wandering pinpricks of light that drifted slowly against the familiar tapestry of constellations. These restless wanderers, the ancient Greeks called asteroids planetae, wandering stars. Most moved with stately regularity, but a few, far dimmer and subtler, barely left a trace on the nightly sky. It would be centuries before humanity understood that some of these elusive motes were not planets at all, but asteroids, fragments of cosmic history, scattered like breadcrumbs across the solar system. To study the asteroids is to peer into the dark, both literally and in the sense of unraveling mysteries that seem always just beyond reach. The story of how we learn to track, characterize, and even touch these distant rocks is a tale of ingenuity and patience, of night watchers hunched over telescopes, of film plates and blinking monitors, of spacecraft venturing farther than any human hand could reach. Let us drift together through the tools and turning points that shaped our understanding, listening quietly for the faint echoes of discovery that still reverberate in the silent dark. The first chapter of asteroid exploration was written not with rocket science, but with glass and patience. In the early 19th century, astronomers scoured the night sky with telescopes that by modern standards were modest indeed. The quest began in earnest with the search for a missing planet between Mars and Jupiter, a gap identified by the Titius-Bode law, a mathematical curiosity that suggested a planet ought to be orbiting at that empty distance from the Sun. On New Year's Day, 1801, Giuseppe Piazzi, an Italian priest and astronomer, found a star-like point that seemed to shift position from night to night. He had discovered Ceres, the first and largest asteroid, though at first he suspected it might be a star or a comet. Piazzi's tools were simple: a refracting telescope, an exquisitely detailed star map, and a notebook where he recorded the tiny changes in position that betrayed Ceres's movement. Each night he would check the same patch of sky, looking for any point of light that appeared where it should not, or moved when it ought to stand still. There was no instant verification, no computer to compare images, just the slow, deliberate act of watching and recording, letting the sky reveal its secrets at its own pace. The years that followed saw the discovery of Pallas, Juno, and Vesta, each found independently by astronomers who, like Piazzi, relied on the painstaking art of celestial cartography. They mapped the heavens by hand, marking the locations of each star, searching for the telltale wanderers. These first asteroids were just the beginning. As telescopes grew in size and precision, the number of known asteroids swelled from a handful to 100, then 1,000, then tens of thousands. The darkness between Mars and Jupiter, once thought empty, was alive with motion, but the tools of discovery were changing too. The invention of photographic plates in the late 19th century transformed astronomy. Instead of relying on the human eye and memory, astronomers could now capture entire fields of stars in a single exposure, then return later to compare one plate with another. In the quiet glow of red safelights, researchers would lay two glass plates side by side, peering through a device called a blink comparator, a simple but ingenious machine that let the user flip rapidly between images. Stars would remain fixed, but anything that moved, a comet, an asteroid, sometimes even a planet, would seem to jump back and forth, a flickering ghost on the edge of vision. One of the most famous uses of this technique came in 1930, when Clyde Tombaugh, an amateur astronomer from Kansas, was hired by the Lowell Observatory to search for a new planet beyond Neptune. Night after night, Tombaugh exposed photographic plates to the sky, each one capturing the faintest pinpricks of light. With patient determination, he compared pairs of plates using the blink comparator. On a snowy February evening, he spotted a tiny moving dot, Pluto, the last of the classical planets, and itself a denizen of the dark, icy outer reaches. But Tombaugh's plates also revealed a wealth of asteroids, their subtle wanderings recorded forever in silver emulsion. As the 20th century unfolded, the tools grew ever more sophisticated. Telescopes climbed to mountaintops and spread their domes across desert plateaus, chasing clearer air and darker skies. The finest glass was ground to mirror-smooth perfection, reflecting distant starlight into cameras cooled to catch every photon. With the arrival of electronic detectors, first photomultiplier tubes, then charge-coupled devices, or CCDs, the sensitivity of telescopes leapt forward again. Now even the faintest asteroids, invisible to all but the most powerful instruments, could be detected and tracked. But even as the tools of detection improved, the challenge remained: how to pick out the glimmer of an asteroid from the sea of stars. Here too human ingenuity prevailed. Modern surveys, like the Lincoln Near-Earth Asteroid Research, LINEA, or the Catalina Sky Survey, employ software to compare nightly images, scanning for any point of light that shifts position or brightens unexpectedly. When a candidate asteroid is found, its position is relayed to a global network of astronomers who race to confirm the discovery and calculate its orbit. The process is now almost instantaneous, but the heart of it, comparing the sky night after night for movements in the darkness, echoes the methods of Piazzi and his peers. Yet seeing an asteroid is only the beginning. To truly understand these relics of the solar system, we must probe them more deeply, measuring their composition, their shape, their motion through space. Here too, our tools have evolved in marvelous ways. Spectroscopy, the science of light unraveled, opened a new window onto these distant rocks. When sunlight strikes an asteroid, some wavelengths are absorbed, others reflected, each according to the minerals on the surface. By splitting the light with a prism or diffraction grating and measuring the resulting spectrum, astronomers can infer whether an asteroid is rich in metal, coated with carbon, or made mostly of silicate rock. Some spectra reveal the telltale signature of hydrated minerals, evidence that water, in some ancient epoch, once touched the asteroid's surface. Radar, another gift of modern technology, allows us to bounce radio waves off nearby asteroids and listen for their echoes. At first, radar astronomy was the stuff of science fiction. Its early experiments conducted with surplus military equipment in the aftermath of World War II. But as the technique matured, it became possible to map the shapes and spin rates of asteroids with remarkable precision. The Arecibo Observatory in Puerto Rico, with its vast dish nestled in the karst hills, became a radio ear pressed against the sky, listening for the faint return of signals sent across millions of kilometers. With radar, we could see not just the position of an asteroid, but its contours, ridges and craters, moonlets, and oddly elongated forms. Still, there is only so much that can be learned from afar. The ultimate tool, the boldest step, is to send a spacecraft across the void to meet an asteroid face to face. This is a feat that only our own age has accomplished, and each mission has brought the dark world of asteroids into dazzling intimate focus. The first attempted rendezvous was a modest one. NASA's Pioneer 10, launched in 1972, passed within a cosmic stone's throw of asteroid 307 Nike, but the flyby was too distant for meaningful data. It was not until 1991 that the Galileo spacecraft captured the first close-up images of asteroid 951 Gaspra, revealing a battered, lumpy world pocked with craters, an ancient survivor of endless collisions. 2 years later, Galileo would pass by Ida, discovering to the astonishment of scientists that it possessed its own tiny moon, Dactyl. The notion that asteroids could have satellites of their own was new and forced astronomers to reconsider how these bodies formed and survived. With each subsequent mission, our reach extended further. In 1996, the Near-Shoemaker spacecraft was launched toward 433 Eros, a potato-shaped near-Earth asteroid. After a year of orbiting and mapping, in 2001 the spacecraft made a controlled descent to the surface, transmitting data until its final moments. For the first time, we had touched an asteroid, if only with robotic fingers. Other missions followed, each more ambitious than the last. Japan's Hayabusa and Hayabusa 2 missions visited the asteroids Itokawa and Ryugu, scooping up grains of dust and returning them to Earth. The samples were precious beyond measure, tiny fragments that had never been touched by weather or water, carrying the pristine story of the solar system's birth. NASA's OSIRIS-REx spacecraft, in its turn, journeyed to the asteroid Bennu, mapping its surface in exquisite detail before reaching out with a robotic arm to collect a cache of primordial material. These missions transformed our understanding. From close range, asteroids are not just points of light, but worlds in miniature. Their surfaces are strewn with boulders, sometimes covered in regolith as fine as flour, or riven with fractures from ancient impacts. Some spin with dizzying speed, while others tumble lazily through space. Many are not solid rocks, but rubble piles, loose assemblages of fragments held together by gravity and the faintest whisper of cohesion. Such structures are revealed by the way an asteroid's shape changes as it rotates, or how its surface shudders when struck by a tiny impactor. But even as our gaze sharpens, mysteries remain. The Yarkovsky effect, for example, is a subtle force that nudges asteroids over millions of years. It arises from the way sunlight warms the surface, which then re-emits heat as infrared radiation, giving a tiny push, almost like a gentle breath against the body. This effect, invisible to the eye, can over time shift the orbit of an asteroid, making the task of predicting future positions a delicate dance of physics and observation. To measure it, astronomers combine precise telescopic tracking with thermal models, piecing together the invisible hand that guides these wanderers. There are, too, the stories told by meteorites, asteroid fragments that have fallen to Earth. Each one is a sample return mission gifted by nature, a piece of stone or metal formed in the deep past, heated in the fires of entry, yet still carrying isotopic secrets in its minerals. Laboratories on Earth are equipped with mass spectrometers and electron microscopes, able to probe these relics at the atomic scale. From their composition, we learn of the processes that shaped the early solar system: melting, differentiation, the slow accretion of dust and ice. All these tools, telescopes, spectrometers, radar dishes, spacecraft, and the humble microscope, form a symphony of exploration, each instrument tuned to a different note in the song of the asteroids. Together, they have revealed a universe more subtle and strange than anyone could have imagined 2 centuries ago, when Piazzi first glimpsed a moving speck among the stars. And yet, as we continue to peer into the dark, The sky is ever generous with new questions. Each discovery leads to another. Each tool uncovers another layer. The more we see, the more we realize how much lies hidden, how the faintest glimmer on a photographic plate might point the way to a new world, how the echo of a radar pulse might reveal a moonlet circling in the dusk. So the vigil continues beneath the patient stars, with eyes and instruments tuned to the dark. The asteroids remain our guides, their orbits slowly shifting, their surfaces whispering of ancient collisions and silent ages. In the next chapter, we will follow their journey onward, toward Earth, toward the future, and toward the riddles that still await in the silent reaches of space. Across the silent stage of night, beneath the slow sweep of stars and the hush that comes only when most of humanity sleeps, the sky is not as empty as it seems. Even as you read this, asteroids, those ancient wandering stones, continue their tireless orbits. Some slip past us, closer than the moon, unseen by all but the most attentive watchers. Others glide through the distant reaches of the solar system, their existence inferred by the faintest flicker of starlight or the lingering echo of a radar pulse. And in this quiet, ceaseless cosmic ballet, there unfolds a dance of proximity and distance, of chance and certainty, that invites us to reflect not just on what is out there, but on who we are and how we fit into this immense, unfolding story. It is a strange thing to consider that the earth, so solid underfoot, so seemingly eternal, is, in truth, a moving participant in this grand choreography. For billions of years, the planet has been a dancer itself, pirouetting around the sun, weaving between the paths of asteroids and comets like a figure on a crowded floor. The scars of past encounters are written deep into its surface. Ancient craters, silent and overgrown, are the fossilized footprints of cosmic visitors. To look up at the sky, then, is to contemplate a universe in which collision and near miss are as fundamental as gravity itself. What does it mean to live in such a universe? To be, as the poet said, children of chance and necessity, adrift on a world that spins through fields of stone. For some, the knowledge of near-Earth asteroids brings a tremor of unease. The sheer possibility that at any moment the normal course of things might be upended by a visitor from the dark can feel like a reminder of our vulnerability. But there is another way to see it, a way that is perhaps more in keeping with the long view of the cosmos. To stand on Earth, conscious and curious, is to be both spectator and participant in the cosmic dance. Our awareness of asteroids, their paths, their histories, their potential, connects us to the universe in ways both profound and subtle. We are, after all, not merely threatened by these wandering stones. We are kin to them, formed from the same dust and fire, shaped by the same laws of motion and chance. In fact, the story of life on Earth is inseparable from the story of asteroids. It may well be that, without the rain of carbon-rich meteorites in the planet's youth, the building blocks of biology would never have arrived. The seeds of amino acids, sugars, and other organic molecules, delivered perhaps on the backs of comets and asteroids, might have tipped the balance toward life's emergence. So, as we reflect on the close approaches of these ancient travelers, we are not only contemplating danger, we are also considering the deep interweaving of fate and fortune, of destruction and creation. Each asteroid that passes by is a reminder that the universe is not fixed, not safe, not finished. It is a place of becoming, of ongoing change, where the story is still being written. There is, in the watchfulness of astronomers, a kind of modern myth-making. The act of tracking asteroids, of naming them, plotting their paths, calculating their orbits centuries into the future, is a way of bringing the unknown into the realm of the known. It is a practice as old as humanity itself. Long before telescopes or computers, people looked up and traced the wanderings of planets and stars, seeking meaning in their patterns. Today, the tools are more sophisticated, the mathematics more exact, but the impulse is the same: to read the sky, to find our place in the moving tapestry of the heavens. And yet, for all our vigilance, there remains a fundamental unpredictability. The universe is not a clockwork machine. Even as we chart the courses of thousands of near-Earth objects, the limits of our knowledge are always present. A small alteration, a nudge from Jupiter's gravity, a subtle outgassing from a sun-warmed asteroid, a collision in the dark, can shift an orbit just enough to change everything. This is not a failure of science, but a reflection of the deep complexity of the cosmos. It is a humbling reminder that, for all our intelligence, we are still learning, still watching, still hoping to understand. In this uncertainty lies a profound philosophical lesson. The dance of asteroids is not just a story of threat, but a meditation on the nature of uncertainty itself. To live well in such a universe is to embrace the unknown, to cultivate a kind of cosmic humility. We are wise, perhaps, to prepare and to plan, to build telescopes and craft strategies for deflection. But we are also wise to recognize that not everything can be foreseen or controlled. There is a serenity in accepting that some aspects of existence are, and always will be, beyond prediction. This knowledge can be unsettling, but it can also be liberating. When we realize that the universe is more like a dance than a machine, more like a story than a blueprint, we open ourselves to wonder. The close approach of an asteroid is, in one sense, a brush with oblivion, but in another, it is a reminder of the astonishing improbability of our own existence. For every stone that passes by, unseen and harmless, there is the uncountable chance that life continues, that civilizations endure, that we have another day to gaze up in awe. Consider the idea of cosmic perspective, that shift in viewpoint made famous by images of Earth from space. When astronauts describe the overview effect, they speak of a sudden, overwhelming awareness of the fragility and unity of our world. The sight of Earth, small and blue in the darkness, reorders priorities and dissolves boundaries. The knowledge of asteroids, of what passes close, of what might one day arrive, serves a similar purpose. It reminds us that the divisions we draw between nations, between peoples, are vanishingly small compared to the vastness of the sky. The asteroid does not distinguish between continents or creeds. Its path is impartial, its approach unheralded. In the face of such impartiality, the petty squabbles of our species seem for a moment to lose their hold. There is, then, an implicit call to unity in the contemplation of near-Earth asteroids. The work of searching, tracking, and preparing for potential impacts is a global endeavor undertaken by scientists and engineers from every country. It is a project that transcends borders and ideologies because the stakes are shared by all. In this sense, the cosmic threat becomes a catalyst for human connection. The asteroid, indifferent and impersonal, unwittingly invites us to care for one another, to recognize our shared vulnerability and our shared capacity for foresight and cooperation. But the connection goes deeper still. The asteroids, in their way, are not merely threats to be avoided or problems to be solved. They are also messengers, carriers of history, of material, of possibilities, yet unimagined. The same rocks that might one day threaten life on Earth could, in another context, sustain it. As we look to the future, the idea of asteroid mining has moved from the realm of science fiction into the domain of serious engineering and policy discussion. The metals and minerals locked within these bodies, iron, nickel, platinum, water, are resources that could support human activity beyond Earth, enabling outposts on the Moon, Mars, and worlds still farther away. In this sense, the close approach of an asteroid is not only a warning, but an invitation. It beckons us to think beyond immediate fear, to consider the long arc of civilization. What if, in time, the asteroids that once threatened us become the stepping stones for our journey outward? What if the cosmic hazards of today are the cosmic opportunities of tomorrow? Here is another reminder of the universe's paradoxical nature. That which endangers can also enable. That which destroys can also create. There is a quiet poetry in this realization. The same impact that ended the reign of the dinosaurs, that reset the course of evolution 66 million years ago, also made room for the rise of mammals, for the eventual emergence of beings who could ponder their own origins. The asteroid is both the harbinger of endings and the midwife of new beginnings. In this, we glimpse the larger cycles of cosmic history, where creation and destruction are inseparable, where every catastrophe is also a turning point. This perspective can reshape our sense of time. Human lifespans are fleeting, a few decades, a handful of generations. Even the rise and fall of civilizations are brief flickers compared to the slow turning of planets and the ancient drift of asteroids. Yet, through science, we have learned to stretch our imagination across eons. We can trace the history of impacts, reconstruct the paths of long-vanished objects, and project the future courses of those still wandering. In contemplating the cosmic dance of asteroids, we are invited to adopt this longer, deeper view. We become for a moment citizens not just of nations or cultures, but of time itself, participants in a story that began before us and will continue long after. And so, as you lie in the quiet, perhaps listening to the distant hum of night, you are joined, whether you know it or not, by these silent companions. Somewhere overhead, a stone a mile wide may be passing unseen, older than any mountain, older than any word. Its path is shaped by forces as subtle as sunlight and as immense as Jupiter's gravity. It does not know you, and yet, in the great web of cosmic connection, it is not wholly separate. Its existence is interwoven with your own, as your existence is interwoven with the planet beneath you and the star that warms your days. To reflect on this is to encounter a kind of cosmic intimacy, not the closeness of touch or speech, but the intimacy of shared origin and mutual dependence. We are, all of us, the children of stars and stone. The iron in your blood was forged in the heart of a supernova. The water in your cells may have arrived on the back of a comet. The asteroids are not strangers then, but long-lost relatives, circling back through time to remind us of our place in the family of things. There is wonder, too, in the knowledge that our story is still unfolding. As our technology improves, as our understanding deepens, we are poised at the edge of new chapters. Perhaps, in years to come, we will send missions to rendezvous with asteroids, to learn their secrets firsthand, to harness their resources, or even to deflect those that threaten harm. Perhaps, too, we will learn to see ourselves differently, not as passive inhabitants of a vulnerable world, but as active participants in the shaping of our destiny. But even as we dream of futures bright and strange, the core lesson remains. The universe is a place of ceaseless motion, of endless encounter. The cosmic tango continues, with Earth and asteroids tracing their silent arcs through the dark. Each close approach is a reminder, sometimes gentle, sometimes stark, that we are part of something vast, intricate, and unfinished. And so, as the night deepens and the stars wheel overhead, let your thoughts drift outward, beyond the walls of your room, beyond the city and the hills, beyond the blue shield of atmosphere that guards against the small debris of space. Let your mind travel with the asteroids, feel the pull of gravity and the warmth of distant sunlight, and rest for a moment in the knowledge that you are part of the dance. The universe is not finished. The story is not yet told. The stones are still moving, the orbit still shifting, and somewhere in the silent dark, new possibilities are gathering, awaiting their turn on the cosmic stage. And so, our journey through the quiet paths of the cosmos gently drifts to a close, like a comet tail fading into the hush of space. As you rest beneath the vast, starlit sky, may your thoughts wander peacefully among the silent travelers of the night. Return soon, dear dreamers, for more celestial mysteries await to cradle you in their cosmic embrace.